To talk about the results of my case study in talent management. Let's get started. So we're going to talk about what are the primary drivers of attrition. We're going to look at the identification of some job role specific trends. We're going to create a model for predicting attrition, and then we're going to create another model for predicting monthly salary information. So first question of interest, what causes attrition? So our data set's got about 38 variables concerning employee retention. I think that attrition probably has many root causes, and I think that identifying 3 variables from the data set that most contribute might not paint the whole picture of who stays at a company and who leaves the company. So to remedy this, I'm going to use a technique called principal component analysis. So the main idea is that we're going to take the data set, we're going to perform some calculations on it up in MathLand, and what that's going to do is we're going to rearrange the variables as linear combinations of one another, and those combinations are going to be called principal components. Each of those principal components is going to contain all of the 27 original variables, except that now, instead of 27 variables, we just have these principal components that we're going to talk about. So let's talk about how I eliminated some of the variables out of the original data set. So my plan the whole time was to use PCA to reduce the dimensions of the data, but before that I had to strip down some of the variables out of the original data set. So I selected 27 of the original variables, so I took out a lot of information on salaries, so I took out daily rate, monthly rate, and hourly rate, and I just kept monthly income because the other variables were too inconsistent. So I got rid of a lot of the non-varying variables, such as over 18 and total workweek hours, because they were all 80 and yes, so those provided no information as far as the analysis. So at the end of the day, the PC reduced 27 variables down to 15 components, and those 15 components accounted for 81% of the total variation in the data. And that's great because originally we had 27 variables that accounted for 100% of the variation in the data. So we eliminated 12 and lost very little information. As I said before, each PC is a linear combination of the original 27 variables now contained in what's called principal components. So let's talk about how I selected these components. So what we've got here is called a scree plot. A scree plot talks about principal components and how much variation each component accounts for. The first principal component accounts for a good chunk of the variation, about 20%, so we're definitely going to keep that one. And then we're going to keep the next 14 variables. So those 15, like I said, combined account for 21% of the data variance. So, and a lot of those PCs have information on attrition in them. So let's go ahead and take a look at them. So we've got these things called loadings in our PCs, and like I said, each of the principal components has the original 27 variables in it. So we can look at the absolute magnitude of some of these loadings, and these are the variables that we're familiar with. So PC1, which contains a whole lot of our information in the data set, so it's positively associated with total working years, years at company, job level, and monthly income. So what we can do is we can interpret this PC as a measure of career length and longevity, as well as a general measure of success. Same thing for principal component number 2, absolute magnitude. So we've got number of companies worked at, age, years with current manager, and years in current role. So this is a little bit more nuanced, but we can just say that this is a general characteristic of an employee as far as how many companies they've worked at, monthly income, and we can say that these all sort of vary together. Same thing for principal component 3, we've got performance rating, percent salary, height, department, and job role. So the interpretation of that is similar to the previous two. I want to go ahead and talk about principal component number 4 because I think this is a really interesting takeaway. So we've got principal component 4 is positively associated with stock option level, and it's negatively associated with marital status. So we can say that principal component 4, when stock option level increases, we can say that marital status decreases. That's pretty interesting. That might play into what we're getting at here. So we've got these things called biplots right here. So these biplots plot the principal components and the direction and magnitude of the loadings in those components. So we can see here that the blue is attrition, and we've got a general trend of attrition towards the first quadrant in that plot there. So we can see that job role, marital status, percent salary hike, and job satisfaction look like they play an important role in who's going to leave a company and who's going to maybe not leave a company. So let's go ahead and take a look at the biplot for PC2 and PC3. So we can see that we got job role once again. Marital status and years since last promotion seem to play a big role in those who leave their companies. So again, let's look at PC3 and PC4. So we've got age, monthly income, marital status, and department. Notice that a couple of these are appearing more than once, so we can say certain things about them. So it's starting to look like marital status, job role, age, monthly income. Those are some really important factors in what might cause an employee to leave their company. So a couple takeaways here. Principal components are really useful, and we can kind of group our variables together and say general things about employees and use each of the components to make general assumptions about an employee's performance. We look in those biplots to see the general trends of magnitude of the loadings that make up each principal component. So next up, we're going to talk about job role specific trends. So we can see here that we use principal component analysis again, that each of the job roles is encompassed in one of these ellipses here. So we can see that if you want to be a manager or a sales representative, you probably got to work a lot of years. However, on the other end of the spectrum, if we've got someone like a sales executive or a laboratory technician, total working years isn't as important as maybe number of companies worked as or years with current manager. And then we've got some job roles that even point towards attrition, which is really interesting. So we found out that job roles tend to cluster around each other. Certain roles tend to be more positively associated with loadings from the first two principal components. Managers and research directors are more heavily associated with years of experience, and sales representatives are associated with attrition in the negative direction. So my advice would be that if you want to change your job role, you should develop attributes more in line with the intended role based on this plot. All right, so next up, we used a naive Bayes classifier, and then we found out that naive Bayes works pretty well. It's got about 81% accuracy, 86% sensitivity, and 76% specificity. And then we also used regularized discriminant analysis, so great for binary classification. 85% accuracy, 87% sensitivity, 83% specificity. All right, so the next thing is salary classification. So we just used linear regression. It's more nuanced compared to attrition, and salary information is a continuous variable. Our RMSE is $1,368, and our entire model is significant. All four predictors are below 0.05. General model is below 0.05. 91% of the variance is accounted for. And we only used 4 variables to create this. So that's all. Thanks so much for watching.